Ready for a journey into the unknown? Buckle up, because today we're tackling some of the biggest mysteries in science. The kind of questions that have puzzled brilliant minds for centuries. And we're going deep. We've got articles and research papers. Oh, and even some of my own notes.
Sounds exciting.
It is. It's all about the things that make us go, wait, what? You know what I mean?
It's pretty amazing to think that we're alive right now when we're actually starting to unravel some of these long-standing mysteries.
Right. And that's what we're doing today. A deep dive into, well, I guess you could say the cosmic unknown, the mysteries of our own minds, even the possibility of life beyond Earth. We'll be looking at everything from dark matter.
To the wow signal. A pretty fascinating mix of topics. I think this really shows how interconnected everything is, from the vastness of space to, well, the inner workings of our brains.
Okay, so let's start with something that's literally all around us, but we can't even see it. Dark matter. I was reading this amazing analogy in one of the articles. Imagine you're looking at a city skyline, right? All those skyscrapers reaching for the clouds.
Okay.
But what you can't see is the steel framework holding it all together, providing the structure and support. That's kind of what dark matter is like. It's this unseen substance that makes up a huge chunk of the universe. And scientists think it's the gravitational glue holding galaxies together.
Yeah. The intriguing part is that we can observe its effects, like the way galaxies rotate. That suggests there's way more mass there than we can actually see.
So we know it's there,
Mm-hmm.
but we don't know what it is. That's kind of frustrating, isn't it? What are scientists saying? What are some of the leading theories about what dark matter could be made of?
Well, there are a few contenders. One possibility is that it's made up of these things called weakly interacting massive particles. Yep, WIMPs. And these hypothetical particles, they would only interact with regular matter through, well, weak forces and gravity. And that would make them incredibly difficult to detect.
Okay, that makes sense. But how are scientists actually trying to find these elusive particles?
Well, some researchers have built these incredibly sensitive detectors, and they've put them deep underground.
Oh, to shield them from cosmic rays.
Exactly. They're hoping to catch a glimpse of a WIMP interacting with ordinary matter.
Oh, so they're just waiting.
Yeah, pretty much. But there are other scientists who are using particle accelerators, like the Large Hadron Collider.
Oh, wow.
Yeah, to smash particles together at incredibly high energies, hoping to create dark matter particles. In the process, obviously.
Wow, so that's some serious detective work. It reminds me of those old mystery novels where they have to piece together clues to solve the case.
It is kind of like that, isn't it? It's a scientific puzzle, but like on a cosmic scale.
And then there's dark energy, which seems even more bizarre, right?
Yeah.
From what I've read, it's this force that's causing the expansion of the universe to accelerate. It's like someone hit the gas pedal on the universe.
That's a good way to put it. And unlike dark matter, which pulls things together, dark energy seems to be pushing everything apart.
Okay, I'm trying to picture this.
Think of it like you're inflating a balloon, but the balloon just keeps expanding faster and faster.
So what does this mean for the future of the universe? Will it just keep expanding forever?
That's one of the big questions cosmologists are trying to figure out, If dark energy continues to dominate, the universe could expand indefinitely, eventually becoming, well, a pretty bleak place. Cold, dark, and empty.
Okay, that is kind of a bleak thought.
Yeah.
But hey, maybe by the time that happens, we'll have figured out how to travel to other universes.
Maybe.
Speaking of mind-bending concepts, let's move from the vastness of the cosmos to something equally mysterious. The inner workings of our own minds. What is consciousness? And how do our brains create this experience of being, of self-awareness? It's something we all experience, right? But it's so hard to define.
You've hit on one of the most fundamental questions in science and philosophy, for that matter. How do physical processes in the brain give rise to, well, subjective experiences, like thoughts, feelings, our sense of self? This is often called the hard problem of consciousness.
So the hard problem, basically, we're trying to figure out how the material stuff of our brains creates the immaterial stuff of our minds.
Exactly.
Okay. So what are some of the approaches researchers are taking to try and crack this problem?
There are a lot of different avenues of research going on right now. Some scientists are focusing on mapping brain activity, trying to identify specific neural patterns associated with different conscious experiences. Others are exploring the role of quantum mechanics in consciousness.
Quantum mechanics and consciousness.
Yeah, it's pretty wild. They're suggesting that quantum processes in the brain might actually play a role in generating subjective experience.
Wow, that's a combination I wasn't expecting.
Right?
It seems like there's still so much we don't know about how our own minds work. But the fact that we're even able to ask these questions, to ponder the nature of our own existence, that's pretty amazing, don't you think?
Absolutely. And the more we learn about the brain, the more we realize how complex and fascinating it is. It really is like a universe unto itself.
And speaking of universes, how about the idea that our universe might not be the only one? The concept of a multiverse, where countless other universes exist alongside our own.
Right.
It's enough to make your head spin.
Oh, it is. It is. It's a pretty mind-expanding idea. The multiverse, well, it arises from certain interpretations of quantum mechanics and string theory. These interpretations suggest there could be an infinite number of universes, each with its own set of physical laws and constants.
So there could be universes where gravity works differently, or where time flows backward.
Exactly. Some universes might be similar to ours, while others could be so radically different it's hard to even imagine them.
Wow.
Some might even have different dimensions of space and time.
That opens up a whole new realm of possibilities. But if we can't see or interact with these other universes, how can we even know if they exist?
Well, that's a challenge, isn't it? Direct observation of other universes might be impossible, at least with our current technology.
Right.
However, some physicists believe we might be able to find indirect evidence.
Oh, really? How?
Well, they say that we might be able to find it through subtle anomalies in our own universe, like patterns in the cosmic microwave background radiation, for example.
So we're looking for those subtle hints, those whispers from other realities. It's like trying to find a message in a bottle that's drifted across the cosmic ocean. And speaking of mysteries that have us searching for signals, let's dive into the WOW signal. I'm sure you're familiar with this one. A powerful radio signal detected back in 1977. That seemed to come from deep space.
Oh yeah, the wow signal. It's definitely one of the most intriguing puzzles in the search for extraterrestrial intelligence. It was a strong, narrowband signal, lasted for 72 seconds, and it perfectly matched what we think a potential alien transmission would look like.
Yeah. And to make it even more mysterious, it's never been detected again, even though there have been tons of attempts to reobserve that same region of the sky.
Right, and that makes it so hard to figure out. Was it a natural phenomena that we just don't understand yet? A glitch in the equipment? Or an actual signal from an alien civilization? I mean, we might never know for sure.
It's a mystery that keeps people guessing, that's for sure. It really makes you wonder if there are other intelligent beings out there trying to reach across the vastness of space.
It's definitely a possibility. And, the search for extraterrestrial intelligence continues. We've got increasingly sophisticated technology and a growing network of researchers all over the world.
Well, that's encouraging. Speaking of searching for answers, let's shift our focus from the distant reaches of space to something a little closer to home, the depths of our own planet.
Okay.
We've explored less than 5% of the ocean, which means there's a whole lot we haven't seen.
Oh, yeah, for sure.
What are some of the biggest mysteries hiding down there?
Well, the ocean is a pretty vast and mysterious place. It's teeming with life that we're only beginning to understand. One of the most interesting areas, I think, are those deep ocean trenches.
Right.
The pressure is immense down there. Sunlight never even reaches.
Wow.
And in these extreme environments, life finds a way to thrive, often in ways that, well, that we just wouldn't expect.
You mentioned extreme environments. What about hydrothermal vents? I was reading about those. They're like underwater geysers, right?
Yeah.
Spewing out superheated water and chemicals. And somehow, life not only survives there, it thrives.
I know, it's pretty amazing. These vent ecosystems are completely independent of sunlight. They rely on chemosynthesis instead. It's a process where microbes convert chemicals from the vents into energy. It's a totally different way of life than what we're used to seeing on land.
It makes you wonder if life on other planets might have evolved in similar ways, maybe in subsurface oceans or around hydrothermal vents.
That's definitely a real possibility. Astrobiologists are really interested in these extreme environments here on Earth. They see them as models for what life might look like on other worlds.
So in a way, by studying the depths of our own ocean, we might be getting a glimpse into the potential for life beyond Earth.
You could say that.
That's pretty amazing. But let's face it, even the most advanced technology can't solve every mystery. Some questions might just be beyond our understanding, at least for now, like the nature of time. Why does it seem to flow in one direction? Is time travel even possible?
These are some big questions for sure. I mean, people have been pondering these things for centuries. Our everyday experience tells us that time flows linearly, past to present to future. But modern physics, especially Einstein's theory of relativity, suggests that time is a lot more complex than we think.
Okay, so Einstein comes along and shakes things up. Again, how does relativity change our understanding of time?
Well, relativity tells us that time isn't absolute. It's actually relative to the observer's frame of reference. Time can be affected by gravity and motion.
Hmm.
The faster you move, or the stronger the gravitational field you're in, the slower time passes for you compared to someone in a different frame of reference.
So time isn't this constant, unyielding river. It's more like a flexible stream, maybe,
Mm.
one that can speed up or slow down depending on where you are and how fast you're moving.
That's a good way to put it. And it opens up some pretty crazy possibilities. For example, if you could travel at speeds close to the speed of light, time would slow down significantly for you compared to someone back on Earth. You could basically travel to the future.
So time travel to the future might be possible. That's like straight out of science fiction.
I know, right?
But what about traveling to the past? Is that even theoretically possible?
That's where things get tricky. While relativity doesn't explicitly rule out time travel to the past, it requires some pretty exotic physics, like wormholes, or maybe some other kind of distortion in space-time. And even then, there are a lot of paradoxes to think about.
Paradoxes? Like what?
Well, there's the classic grandfather paradox.
Oh, yeah, I've heard of that.
Okay, so imagine you travel back in time
Mm-hmm.
and you accidentally kill your grandfather before your father is born.
Okay.
If your grandfather is dead, then your father wouldn't exist, and neither would you. But if you don't exist, how could you have traveled back in time to kill your grandfather in the first place? See, it creates a logical inconsistency.
Yeah, I see what you mean. It's a real head scratcher. It
Yeah.
seems like the more we learn about time, the more mysterious it becomes.
Exactly. But I think that's part of what makes it so fascinating.
I agree. Speaking of pushing boundaries, let's delve into another realm where science and imagination collide. The world of black holes.
Ooh, yes.
These cosmic monsters are regions of space-time where gravity is so strong, nothing, not even light, can escape. What exactly are these things, and what mysteries do they hold?
Black holes are one of the most extreme and fascinating predictions of Einstein's theory of general relativity. They form when massive stars collapse at the end of their lives. They create regions of space-time where gravity is so strong that it warps the fabric of the universe itself.
So imagine you're on a trampoline, and you place a bowling ball in the center. It creates a dip, right?
Yeah.
That's kind of what a black hole does to space-time.
Exactly. Good analogy. And just like objects on the trampoline would roll towards the bowling ball, anything that gets too close to a black hole will be drawn in by its immense gravitational pull.
But what happens to those things that fall into a black hole? Do they get crushed into oblivion?
Well, according to our current understanding, anything that crosses the event horizon, the point of no return around a black hole, is pulled toward the singularity at the center.
The singularity. What's that?
The singularity is a point of infinite density, where all the laws of physics as we know them break down. It's where space and time as we understand them cease to exist.
Okay. Wow, that is intense. So we're talking about regions of the universe where the very fabric of reality unravels. It's almost impossible to even grasp. And then there's the black hole information paradox,
Yeah.
which sounds like something straight out of a sci-fi novel.
Oh yeah, that one. The information paradox comes from the clash between general relativity, which governs how black holes behave, and quantum mechanics, which says that information can't be destroyed. See, if things fall into a black hole and are lost forever, it seems to violate the principles of quantum mechanics.
So where does the information go? Does it just disappear?
That's what we're trying to figure out. Physicists are still trying to reconcile these two fundamental theories and figure out what happens to information that falls into a black hole. Some think that information is encoded on the surface of the black hole and eventually released back into the universe, while others suggest that it might be trapped inside the black hole, maybe in some weird form we don't understand yet.
So black holes are not only cosmic monsters, but cosmic enigmas too. They challenge our understanding of the universe.
You got it. They continue to fascinate and intrigue physicists and astronomers. And every new observation, every new theoretical breakthrough brings us a little bit closer to unlocking the secrets of these weird objects.
Speaking of unlocking secrets, let's turn our attention to another big mystery: the potential for artificial intelligence to achieve consciousness. Can we create machines that actually think and feel? Or is consciousness something that's uniquely human?
This is a question that's causing a lot of debate and speculation right now, especially with artificial intelligence advancing so quickly. Some researchers believe that consciousness is an emergent property of complex systems, and that as AI systems become more sophisticated, they might inevitably develop some form of consciousness.
So it's like if you build a complex enough system, consciousness just kind of pops out.
Yeah, that's one way to think about it.
Yeah.
But other researchers argue that consciousness is more than just complex computation, that it requires something else that current AI systems don't have, like subjective experience maybe, or a sense of self.
So how would we even know if an AI system became conscious? Would it, tell us, would it start writing poetry or composing symphonies?
Well, that's one of the toughest parts. There's no real test for consciousness, and it might be really hard to tell the difference between true consciousness and really good imitation.
Right. It's like the Turing test, but on a much deeper level. We might be fooled by an AI that's really good at acting human, but doesn't actually have any subjective experience.
Exactly. And that brings up some pretty serious ethical questions. Like, if we do create machines that can experience the world in a similar way to humans, do we owe them the same rights and considerations as any other sentient being?
Wow. It's a question that science fiction has been exploring for decades, but now it's becoming more and more relevant as AI technology keeps evolving.
Yeah, it's a conversation we need to start having now, before these technologies become so advanced that we're caught off guard.
I agree. It's important to approach these questions with both scientific rigor and ethical awareness. And I think a bit of humility, too. After all, we're still trying to understand our own consciousness, let alone the potential consciousness of machines.
You said it. The mysteries of consciousness, both human and artificial, really highlight how much we don't know. They're a testament to the vastness of the unknown, I guess you could say, and the limits of our current understanding.
And maybe that's a good place to start for now, right here on the edge of the unknown, with more questions than answers. But hey, isn't that what makes these deep dives so fascinating? It's amazing to think about everything we've covered already in this deep dive.
I know, right?
From the vastness of the cosmos to the intricacies of our own minds. But like any good deep dive, I feel like we always end up with more questions than answers.
Yeah, it's like every time we solve one mystery, it just opens up a dozen more.
Exactly. So as we wrap things up here, exploring these mind-blowing mysteries, let's take a second to recap what we've learned along the way. We started by looking out into those unseen realms of the universe, trying to grasp dark matter and dark energy.
Those invisible forces that really shape how the cosmos is structured
Mm.
and how it changes over time. But we still don't know exactly what they are.
Right. And we talked about all those research efforts to detect dark matter particles and to figure out what dark energy is all about, really pushing the boundaries of physics.
Definitely. And then we went in the opposite direction, exploring consciousness, that experience that makes us, well, us.
Yeah. We thought about the philosophical questions, like the hard problem of consciousness, and whether artificial intelligence could ever become self-aware, like humans.
We talked about how hard it is to define and measure consciousness, and all the ethical things we need to consider as AI gets more advanced. It really brings together science, philosophy, and ethics.
Then we went even bigger, thinking about the multiverse, where our universe is just one of countless others, each with its own laws of physics. We imagine universes with different dimensions, different forms of matter and energy, maybe even different kinds of life.
It really makes you rethink what reality is. Maybe what we see as the universe is just a tiny piece of something much bigger and more complicated.
It is a humbling thought. And then we face those ultimate cosmic monsters. Black holes, places where gravity is so strong that nothing can escape, not even light. We explored all that wild physics, the event horizon, the singularity, where everything we know about physics breaks down.
We even talked about the black hole information paradox, where general relativity and quantum mechanics seem to clash. It shows us that we still have a lot to learn. Maybe we need a new theory to bring those two together.
And we can't forget about the wow signal, that quick but powerful radio signal from deep space. We still don't really know what it was.
It's exciting to think that maybe, just maybe, there's other intelligent life out there.
It is. And closer to home, we explored our own planet, specifically those deep parts of the ocean we haven't explored much, all those unique life forms down there, like those crazy hydrothermal vent ecosystems.
Studying those might even tell us something about how life began on Earth and whether there's life on other planets.
And finally, we took on time itself, questioning why it seems to move in one direction and what Einstein's theory of relativity really means. We even talked about time travel and the paradoxes that come with it.
It's been a wild ride, hasn't it? Exploring all these incredible mysteries.
It really has. It makes you appreciate how much we still have to learn. And for everyone listening, remember, this isn't the end. Keep learning, keep questioning, and never lose that curiosity. You never know what you might discover. Until next time, keep those minds exploring.